Okay, now example 2. We're going to use all those identities that we just talked about, some of them, not all of them, but some of them, to help us to solve these values or find these trig values. So first off, we're going to use the given information to find the trig value of this. So we're saying that secant theta equals 3 over 2. And they want you to find cosine. And so you have to kind of figure out, how do these things go together? How does cosecant and cosine, sorry, not cosecant, but how does secant and cosine go together so that we can go ahead and get this solved and the value found? And hopefully you do remember your identities, because hopefully you remember this here. Secant theta equals 1 over cosine theta, right? Yes, remember that, right? Right. But what else happens? We have another identity that gives us what cosine is equal to. What? Look at that one. What? So we have that cosine and secant go together, but we need to find cosine. And wait, isn't cosine right there? What? And it has secant right there. What? Okay. So then let's try that part and let's go ahead and see what happens if we do that. Instead of putting secant, we know that secant equals 3 over 2. So we're going to put 3 over 2 in for secant. Secant. So we put it on the bottom. And then again, we have to flip it because we know that when it comes to cosine, it's flipping secant, or vice versa. If it's secant, we flip it to make cosine. So here we flip this one, 1 divided by. So you can either say flip it, or we can do this. And either way, it's still the same thing. So if we flip 3 over 2, it's still 2/3. Or if we do keep change flip, and it still gives you 2/3. So cosine theta equals 2/3. What? That was so hard. Oh my gosh. Oh, so hard, Mr. Hall. So hard. Okay, so not bad. All we had to do was substitute the value in from 3 over 2, substitute that in for the secant in the problem, and then we got an answer. Not bad, not bad. Okay, so let's go to part B then. Oh, where's my part B? Where's my part B? I didn't want to show the practice yet. There is part B. Sorry about that. So part B. So this time now they give us cosecant, and we need to find tangent. So we have to figure out, okay, what trig identities has secant and tangent in it, or let's write that out. So here's what you need to ask yourself. Oh, I spelled self wrong. Huh? How do you do that? I did it all by myself. All right, so you ask yourself, what identity has cosecant theta and tangent theta? And so we think about all the identities that we know, not that we just wrote down, but we know. So we know that cosecant is 1 over sine. So sine and tangent, they're not the same thing. Then we have, let's see, we have the Pythagorean identity that says cosecant theta equals 1 plus cotangent squared theta. That doesn't have tangent in it, but can we like do something to cotangent to get tangent? So we can use cotangent to get tangent. And we have an identity that actually deals with cotangent and deals with cosecant. So I'm going to write that out. We have an identity that deals with cotangent theta and cosecant. And if we can do cotangent and cosecant together, that should be able to, we can do things to figure out what tangent is and all that stuff. So the biggest part before we even move on to the rest of this is that you must be able to have a thought process. You have to figure out, how can I get from point A to point B using any of the identities that we have? So it's a thought process that you're going to have to think your way through. Not that it's going to be obvious all the time. Some of these things you will have to actually think your way through, and it might take you some time to actually figure out how to do it. But you must think your way through it using your identities. If you don't have your identities remembered, you cannot think your way through it. You have to constantly look back at their notes and everything to try to figure out how to make it work. Again, this is a thought process that you must think your way through piece by piece to make it work. Almost like it's a proof of going from here to here. That's what all this is you have to make sure that your thought process flows correctly. So here again, because we have cosecant and we have tangent, or we need to find tangent, we have an identity that deals with cosecant and cotangent, and then cotangent is just flipping the tangent part, right? Or vice versa, tangent is flipping cotangent. So we should be able to figure out something using that trig identity with the cotangent and cosecant. So our identity is this, our Pythagorean identity. Well, really, the identity is not written like that. Let's write it the way originally it should be. Let's erase this because that's not the actual identity I gave you. The actual identity I gave you. Oh, let me erase that stuff. Let's do it in blue. The one I actually gave you was 1 plus cotangent squared theta equals cosecant squared theta. That's one I originally gave you. So with that, that's the one it's supposed to be. I'm sorry, I wrote it wrong. I just wrote it wrong a few minutes ago. My bad. So this is the right way. This is the way you had on your notes on the last video. So at this point, we have cotangent. And again, with this, we need to use cosecant to help us find cotangent, and then flip cotangent to find tangent. All right, so with this, I'm going to rewrite this first off so that we can understand what's happening. So whenever you have cotangent theta, cotangent squared theta, that's saying take cotangent and square it. Again, with the cosecant squared, that means we're taking cosecant theta and then we square it. So whatever the actual trig identity is that's being squared, you take that trig, not the trig identity, but you take that trig function that's being squared and you write it down, and then you put the squared on the outside. So cosecant theta squared on the outside. So here, whatever the values they give us for these two, we put them into here and then we square it. So for example, here in our problem, it says that cosecant theta equals 4/3. So here, we would keep all this going here. And we said that this is 4/3 for cosecant. Not cosecant squared, but cosecant. So now what we're going to have to do is go ahead and work this out, which we don't need a calculator for. That's 16/9. Sorry. With this part, don't give me decimals. Decimals are evil. Again, if you give me a decimal for this part here, I'm really going to mark it wrong because that means you use a calculator for something that you don't need a calculator for. Okay. So now, again, we're going to solve this for cotangent so that we can go from there. So it means we need to move this one over. So let me write this. We're going to solve for cotangent. Okay, so if we do that, we're going to subtract 1 from both sides. Let me rewrite this down again. And we're almost done, guys. We're almost done. So we're going to subtract 1 from both sides, like we know that already. And again, we're not using calculators. Calculators are prohibited from this section of the notes. Now, if we're going to subtract 16 over 9 minus 1, that means we have to have a common denominator in order to be able to subtract fractions and whole numbers. So hopefully everybody knows that 1 is anything over itself, and we have to have a common denominator. So that means this would have to be 9 to have a common denominator, and anything over itself is 1. So that means if the denominator is 9, numerator is 9. So 9 over 9 is equal to 1, but that also gives us a common denominator. So cotangent theta squared equals that. And so here that gives me 7 over 9 equals cotangent theta. And then to get cotangent by itself, take the square root, right? Take the square root. So we square root it. There we go. And hopefully you guys remember what happens when you square root numbers. So here this is cotangent theta. And we know we have plus or minus the square root of 7 over the square root of 9. Hopefully you guys remember that part, because you can break it apart. Okay, so here, if we simplify that down, that's plus or minus square root of 7 over 3, right? Because the square root of 7 stays there because it's not a perfect square. Square root of 9 is 3. That's cotangent. And if we're trying to find tangent, we just have to rotate it, flip it. Which here, if we flip it, we know again, cotangent. And this is one of our quotient, our reciprocal identities, not quotient, but reciprocal. So we know where you can use that to find tangent, because that's our whole goal for this problem is to get tangent. So if we rotate this or flip it, that means tangent theta, because we flip, to get this. So tangent theta would be plus or minus 3 over the square root of 7. Don't do that. Over the square root of 7. And then we know we can't have a denominator, a square root and denominator. So I'm going to just rewrite this again. And everybody should know how to simplify radicals and denominators by now. And that's going to be your final answer. And I'm going you to keep it as a fraction, no decimals. So our final answer is this right here. And again, this does require some work and some thought process. So you will have to work. You will have to think. You will have to think, probably like you've never thought before. And if you did this in Math 3, you should know how to do this a little bit more now. But again, you have a thought process and you have to think. Because when you use your mind to take a step at a time, you can do anything that you want to do. Woo! Blue's Clues.